Let's talk about some of the most common trig identities. So, firstly, we have that tan of x is equal to the sine of x divided by the cosine of x. This is very easy, very common. This is the first one that we need. And now we need reciprocal functions. So we have sine, cosine, and tan. Now what if we had 1 over sine? Well, that gets its own name. We call that the cosecant of x, rather cosec of x. And what if you had 1 over cosine of x? Well, we get the secant of x. So it's easy to get confused between 1 over sine being cosecant and 1 over cosine being secant. Just make sure you get that, you understand there's a difference there. And then 1 over tangent is very well, like, this has a good name, and that's called cotangent, and that's easy to remember because it has the word tangent in it. And since it's 1 over tangent, it's also 1 over sine over cosine, which becomes cosine over sine of x. So those are the reciprocal functions. So if I did 1 over sine x all squared, that's like saying cosecant squared, which becomes cosecant squared of x. Some other things that you need to know is that this is another very famous and very common identity, is that sine squared of x plus the cosine squared of x is equal to 1. You can always rearrange this to get cosine squared on its own or sine squared on its own. And then we have 1 plus tan squared of x is equal to the secant squared of x. And we can show this one actually. Let's show this from what we have. So we have 1 plus tan squared. So we have 1 plus sine squared x over cosine squared x. Well, that becomes cosine squared x. If you cross multiply 1 and cosine squared and sine squared, and this is basically 1 over 1. So you have cosine squared plus sine squared divided by cosine squared of x. Well, cos squared plus sine squared is equal to 1, as you saw here. And then 1 over cos squared is like saying 1 over cos of x all squared. But 1 over cos of x is secant of x. So then this all squared becomes the secant squared of x. So that's another one that you can remember, or you can easily derive. As soon as you know this one and you know what these are, you can easily derive any of the others. And there are more as well, but we won't go into it too much. Then now we need to look at when you add two angles together. So sine A plus B. Actually, let's do sine A plus minus B is equal to, so let's say you had two angles. Let's say you had pi over 2 and pi over 4. And let's say you wanted to find the sine of adding those two together. Well, that's the same as the sine of A times the cos of B plus minus sine of B cos of A. So you just give sine of the first angle times cosine of the first angle plus the sine of the second angle times cosine of the first angle. That is if you're doing plus. If you did minus, then you'd have to do the minus sign here. Let's say we had cos A plus or minus B. Well, that's a little bit different. That is cosine of A times cosine of B. And now this is an interesting notation. This is minus plus. And I'll tell you what this means just in 1 second. Minus plus sine A sine B. And minus plus means if you're doing plus for these angles, then you would use minus. And if you're doing minus for these angles, then you would use plus. So make sure you get the difference there. And then we have double angle formula, which are sine 2x. Well, that's just saying that's the same as sine 2a. That's like if you made, instead of b, if you had an a again, what would you get? Well, if you had an a over here and an a over here, then you would have sine a cos a plus sine a cos a, which is basically 2 sine x cos x. And then we have cos 2x. This is a very important one. There are many ways to write this. So one way you can write this is 1 minus 2 sine squared of x. And you can rearrange and you'll find out why all of these are the same. Or you can write it as 2 cos squared x minus 1. So there are two different ways of writing this. So whichever one works for you in the question, make sure you use that one. So let's do an example question and then these will make sense and how we use them. Okay, so let's do this question. We have sec squared theta plus 5 tan squared theta is equal to 9 plus 17 sec theta. Well, we know what tan squared is, right? We know 1 plus tan squared. Oh, was my pen not working? 1 plus tan squared theta is equal to sec squared theta. Well, we can rearrange this, right? We can have tan squared on its own. So that means that tan squared theta is equal to sec squared theta minus 1. We can put that back into this right here. So now we'll have sec squared theta plus 5 tan squared is sec squared minus 1, so we have plus 5 sec squared theta, and then minus 5, because I'm doing 5 times this whole thing. So if I distribute the 5, we have 5 sec squared minus 5, and that's equal to 9 plus 17 sec theta, or secant theta. Well, this is a quadratic equation, but it's in terms of secant theta. So what can we do? We have 1 secant squared plus 5 secant squared. So that becomes 6 secant squared theta. And then we have negative 17 secant theta, if I bring it to the other side. And then bring this to this side as well. We have minus 5 minus 9 is minus 14. And this is equal to 0. So far so good. Now how do we solve this? Well, if we say, let's use y. So if you let y equals secant theta, then this becomes easy to solve. This becomes 6y squared minus 17y minus 14 is equal to 0. So this is very easy to solve. This is just a quadratic equation, right? So how would you solve this? So I don't know if you can factorize it, so I'll just use the formula. So y is equal to 17 plus or minus square root of 17 squared is 289, sorry. Is it 289? Yeah, I think it's 289. 289 minus 4 times 14 times negative 14 actually, times 6. All divided by 2a. So 2 times 6 is just 12. So all of this divided by 12. So what do we get? Let me put this in the calculator. So we get y is equal to, well, 14 times 6 times 4 plus 289. Square root of that is plus or minus 25. So that's nice. Those are nice numbers. So we have 17 plus or minus 25 divided by 12. So we get y1 is equal to 3.5. It's not that bad. And then y2 will be a negative answer, is equal to 17 minus 25 divided by 12 is negative 2 over 3. Okay, so we have two numbers. So we have, but this is y. We don't need y. We need theta. We need an answer in terms of theta between 0 and 360. So if y is equal to secant theta and y is equal to 3.5, then 3.5 is equal to secant theta. But we don't want secant now. Now we want 1 over cosine theta, because that's what secant theta is. Because there's no secant inverse function on your calculator, so this is pointless now. So now we can write it in terms of cosine theta, and we have negative 2 over 3 is equal to 1 over cosine theta. Well, I guess you guys can see what we're going to do next. So we'll have many solutions. So let's make like a table. So let's start with this side right here. So 3.5 is equal to 1 over cosine theta. So if I multiply by cosine theta and then divide by 3.5, so if I bring this to the other side, we get cosine theta is equal to 1 divided by 3.5, which is equal to 2 over 7. So we have cos theta is equal to 2 over 7. And then on this side, we have negative 2 over 3 is equal to 1 over cos theta. So if I do 1 divided by everything, then we get cos theta is equal to 1 over negative 2 over 3, which is negative 3 over 2. But this is equal to negative 1.5. What do we know about cosine theta? We know it only goes between negative 1 and 1, right? We know what cosine looks like. Let's say it's like that. Let's say that's negative 1, that's positive 1, that's negative 1 again. I know it's not to scale, but this is negative 1 and this is positive 1. And this is giving negative 1.5. That means this actually does not have any solutions, because that is just not valid. It just doesn't work like that. Cosine doesn't get you there. The reason we got a negative thing is because we're doing a quadratic equation, so of course we'll get a solution that could potentially be negative. So we don't worry about this side anymore. So now we only work with this right here. Well, cos theta is 2 over 7. We can just do cos inverse on both sides. So I get theta is equal to 73.4 degrees as one of them. And what do we know about cosine? It repeats every 360 degrees. And one way to find out two solutions for cosine is, I'll draw a better cosine graph here. So this is positive 1, negative 1, positive 1. That's 360. And that's 0. And that's 180. A way to find cosine solutions is that if this is one of the solutions, right here, and the other solution will be right here. And the way to get the other solution is you just do 360 minus the initial solution. So if you do 360 minus 73.4, we get 286.6. And that's it. Those are the two solutions we need. We can't do anything on this side right here because I told you cosine doesn't go to negative 1.5. So this can't You can't do anything with this, so we just leave it. And those are our two answers. We only get two answers for theta. And you can put it back into this equation right here, and you will see that it works out. So yeah, that's about trig identities. I hope you learned something, and if you did, then like, share, comment, and subscribe, and let me know what else you want to see in the comments.